Before my introduction, so let me count. So how many students from, the countries other than Taiwan? So if you are international student, please raise your hand. Okay, so many. Thank you. So I also, so many students are, very hard to prepare the midterm exams. Okay, so because, today is Friday, and you know that today is the 13th. So Black 13th Friday. So I think I should, finish this class earlier, and to make sure that you can, safely go back to your dorm or your home. Yeah, because today is very special. Black Friday 13th. So, so I'm very happy, to make this lecture because this is not very technical. This is about the introduction to our department. And maybe, most of you are very strange about our department. So the Civil and Construction Engineering Department. But you know that this department, NTUST, is very famous in Taiwan and even in the global because we have so many contributing graduates right now in industry or even in academic, the research fields. I'm Missing one, and I think the chairman knows me better than I know myself. So. So let me first introduce some milestone of our department. Our department was established in 1975. So is there anyone born earlier than 1975? I think no. But I was born in 1975. So even my hair is very white, but I'm still very young. Okay? So, I was born in 1975, so the same year as NTUST, as this department, Civil and Construction Department. Since 1976, our department offered the bachelor program, and 3 years later, we offered the master program, and since 1983, we offered a PhD program. In 2005, this is a very important milestone because we launched our international student program for graduate students. In 2007 and 2008, we received IET accreditation for undergraduate and graduate students respectively. So these two milestones are also very important because of this accreditation. So after you receive the diploma from this department, you can use this diploma to apply master degree or a PhD degree in the countries which are also accepted by Washington Accord. So later I will give you details about what is a benefit if we have this accreditation and what is a benefit for graduates. No matter you want to find a job or no matter you want to pursue a higher degree. In 2010, we offered dual degree international program. And 4 years ago, we launched international student program for undergraduate students. So those are important milestones for our department. As I mentioned, so why the IEET accredited diploma is so important? Because as shown in this figure, you can see that so this is not the latest information, but we can see that about the Washington Accord signatory and the provision signatories, in total about 23 countries. And in Taiwan and NTUST, our department received this accreditation within 2000 to 2009. So, as I mentioned, we received this accreditation in 2007, 2008, and 2013. So that if once you get the diploma issued by our department, and you can use this diploma to apply the university to apply a PhD or master degrees in this university recognized by Washington Accord. Also, if you don't want to stay in Taiwan, and of course in these classes, the more than half are international students. So of course, you don't need to stay in Taiwan after your graduation. But for domestic students, if you decide to work abroad, you can use this diploma issued by Civil and Construction Department to apply job in these countries, because this diploma is recognized by these countries. So you don't need to worry about, so if you want to apply a job abroad, so nothing to prove. So you don't have any evidence to prove your undergraduate or even graduate degrees. Okay, so this is the issue. If you can receive the diploma issued by our department. About the ranking, in 2023, in the whole world, our university is ranked 327. And in Taiwan, NTUST is ranked the 5th. If we only look at our department, civil, the field, so our department is classified as civil and structural engineering in this field. Then you can see that our department is ranked between 151 to 200. In Taiwan, so our department is ranked third. About the faculty and the staff, the members in our department, right now we have in total 32 full-time faculty members, including 18 full professors, 13 associate professors, and 2 assistant professors. In addition to full-time faculty, we also hire 8 non-tenure faculty members. In addition, we have 3 joint appointment faculty members. We invited some professional researchers from National Taiwan University, National Center for Research on Earthquake Engineering. Also, we have 18 part-time faculty members from industry. So therefore, these professors, these teachers can help our course to be more practical. Okay, so our mission is to make students graduate from our department to be a practical engineer, So in addition to the academic staff, so we also have 8 staff members to support some administration, and some technical jobs. The Professor Cho is the current chairman of our department, and his major is about the reference concrete. So, reference concrete is the most commonly used material in a civil and construction engineering. So, for our department, we have two vice chairmen, Professor Shi and Professor Ten. So Professor Shi, his major is in structure engineering, especially for some dynamic seismic design and signal the processing and the system identification. About Professor Ten, his major is about the geotech, especially for some soil improvement constitutive model for softer soils and so on. We have 5 research divisions, including construction management, construction material, information technology, geotechnical engineering, and structural engineering. For each divisions, there are some important current and future, some potential research topics, like construction management, including computational intelligence, data mining, big data, so how to make a decision and how to support the construction and analysis, design, and so on. And how to mitigate disaster. We know that Taiwan is a multi-hazard place. So why we say this is a multi-hazard? Because we have earthquakes, we have typhoon, we have flood. So therefore, this is based on the official statistics, Taiwan in the global, this is the multi-hazard region. So dispute resolution, the project management and labor safety to provide some strategy so that we can make the environment better for laborers. Construction material, including concrete material, corrosion, circular material, pavement material, and solar glasses. So the last one right now is already used for high-tech industry. Information technology, including BIM, the visual simulation, high performance, the computing, IoT, chat robot, spatial information, including the application of 3D GIS and the point cloud. The geotechnical engineering, including deep excavation, the ground anchor, landslide, the reinforced slope, soil slope, and the rock mechanics. The structural engineering. So I'm one of a professor in this division, structural engineering, including some important topics like, so we, in addition to a new building, new structures, we are also responsible for the maintenance and how to retrofit the damaged structures. So the life cycle management is a very important issue in this field, in this division. And how to repair, how to retrofit damaged structures. In addition to reference concrete and the steel structure, we also propose some advanced composite structures. So it means that we may use a combination of reference concrete and steel, or and any other possible and sustainable materials. Now, smart structure. So right now, this is not sufficient to have a strong structure. This is necessary to develop strong structure. So that's why in the future and right now we try to incorporate some high-tech technology into the structure engineering field, so that we can have a smarter structure by using some structure control devices, or we can use a health monitoring so that after earthquake or after any other attack, so this system can automatically tell owners or residents that this building or this structure is still safe or this is subjected to damage. So the following are the details about all the professors in our department and in this division. So right now, in fact, the Professor Lee, they moved to another university. So right now there are 5 professors in this division. And in the geotech this division, Professor Chen and Professor Liao are retired last semester. And this semester we hired another new professor. So in total, there are 6 professors in this division currently. Let's check. Okay, I forgot to mention. The Professor Cho right now is the Dean of the General Affairs. And the structural engineering, Professor Cho is the chairman, and it's me, and also Professor Chen. So even he retired last semester, but right now this is a director of the Building Structuring in the HASA Mitigation Center. And Professor Xiao, this is the Vice Dean of General Affairs currently. So there are 4 professors in this division, Construction Material Division. And for the Information Technology Division, there are 3. There are 3 professors, and in which Professor Xie, he is Dean of Academic Affairs right now, NTUST. Also, he is the chairman of interdisciplinary bachelor's program. So as I mentioned, so our mission, our goal, the objective of our department is to train students to have ability to carry out experimental work and practical training in a work. So for the arrangement of our courses, we attempt to bridge theory and practice. So we have a balanced emphasis on theoretical, the part, and the practical part. So therefore, in addition to some fundamental theoretical courses, we also arrange some practical training courses. So here are some compulsory courses arranged for undergraduate students. For freshmen, for the 2nd grade, the sophomore, for junior, and for higher students. And also, we arrange some professional practical courses, so that even you do not take any courses, any graduate courses, but you can still have some professional skills. In addition to compulsory courses, we also arrange some elective professional courses for different, which can be divided into 5 research divisions, the same as our research divisions: construction management, geotechnical engineering, structural engineering, construction material, and information technology. Also, we arranged several courses related to civil engineering skill and some practice, so that after taking these courses, even you are an undergraduate student, but you can still have knowledge, the basic information, the basic theoretical materials, and also you can learn some practical and commonly used in practice, some programs, some tools, some commercial softwares. About the graduate courses, these courses can be divided into 5 groups, the same as the 5 research divisions in our department. So the first one, construction management, and second group, geotechnical engineering, third group, structural engineering, and fourth group, construction material, and the fifth group, information technology. Also, in addition to that courses, we also arrange some courses for some special programs, like part-time master program and the dual degree master program. As I explained, we launched the dual degree master program. So that's why we already prepared some courses for this international student to study, to attend this dual degree master program. About the construction management, here are some details about the research focuses in this division. About project management, so how to assess the risk and how to make the decision to make the progress more efficiently, and how to determine the financial, how to plan financial issue, and also how to determine some strategy to have a better management. This is classified as project management. Also, the planning and design, how to estimate the cost, how to estimate the progress, and how to schedule the construction. And the final goal is to have green and smart building, so that we can have environmental friendly material and structures, and also in addition to have a safe structure, we hope that we can have a smarter building. So it means that if we have some damage, so this one can be automatically released. Also, if we need something, we don't need to go out and just use the network Wi-Fi, so that we can monitor everything, we can receive anything. Infrastructure systems, the maintenance. So because we know that the infrastructure, this is quite different compared with the residence building. Because this is, for example, like a bridge, like dams. So how to have good satisfactory maintenance is very important for infrastructure systems. And also we have to reduce the damage caused by disaster. So we need to effectively manage some disasters. And we hope that we can have sustainable engineering, because we hope that the life of the infrastructure system is long enough. The computing in management, so we need some tools, so that we can make some policy, we can make some management, we can make some assessment more efficiently, like AI, artificial intelligence, and some optimization algorithm, and IoT and BIM, and some powerful simulation method, and some powerful simulation tools. About geotech engineering. So we know that Taiwan, the land is very limited. So that's why I say this is a multi-hazard. This issue is very important for Taiwan, the government, and for the residents, because you can imagine that, especially for the west coast of the Taiwan island. So we know that we have a very high, the mountain at the central location, but from the east side to the west side, the distance is very short. So this means that the slope is very significant. That's why, if the raining is out of control, we always have flood issue. And flood issue, if there's no people, live in this region, it's no problem. It's not a big issue. However, Taiwan is very crowded. So we have a very high population, the people population. So therefore, once the raining is out of control, so it means that this is exist the capacity, or this is exist the probability we used to estimate our facility or to estimate our structure. In that case, we usually have a flood issue or some damage. So this is also an important issue for this field, for this division. So also energy sustainable engineering, important issue. In urban geoengineering, so as I mentioned, Taiwan is very crowded, so we so many industry and so many buildings and so many the people are located in some limited cities like Taipei, Taichung, Kaohsiung. So we need to develop some advanced technology so that we can efficiently use the foundation and to provide a safer the foundation for the substructure. Also, in addition to urban, we also need to deal with some rock, the soil, the problem issues. For example, like the landslide issue, as I mentioned. If the raining is very big, if slope is not protected very well, in that case, we may have some landslide issue. And also, Taiwan land is very limited, so the land which can be used very limited, in other words. So therefore, even the ground, the property, the soil property is not satisfactory, but we can use advanced technology to improve the ground property. This is another important issue and another research topic in this division. So for this division, these research topics, our department also provides some useful and some advanced testing systems. So this is a geotechnical laboratory. In this laboratory, we have so many testing systems and so many measurement instrumentation. If you are interested in this field, in this laboratory, so welcome to visit our department anytime. So in addition to geotech lab, we also have a rock mechanics laboratory, this one. So we have a 100-ton capacity server control, the testing system, the machine, as shown in this figure, so that we can apply the compression force or tension force to the spaceman. Also, some like rock fracture toughness testing facility and rock cutting machine and so on. So by using, so when you take the courses, so you can use this the testing system to make you better understand what you learned from the courses. Also, for graduate students, the most of the research you need to perform, you need to carry out some tests. So therefore, the roles of these testing systems in this division are very important. The structural engineering, about life cycle management and rehabilitation, retrofit. As I mentioned, so new building, creating a new building is not only one assignment for structural engineering. Right now, in addition to new structure, we also need to take care the whole life of the building. So therefore, we need to pay attention to life cycle management and also how to effectively retrofit the damaged structures. The structure, reinforced concrete, steel, and even hybrid composite. And also, in addition to the structural or non-structural or infrastructure, how to consider earthquake, how to consider window. This issue is also very important. Of course, this is no problem to make a very strong structure, but this is not cost-effective. This is not efficient. So therefore, we quantitatively define a criteria in a design requirement. As per this defined criteria, then we can design and structure structures with considering suitable seismic load and wind load. However, this is a design and analysis stage. As I mentioned, being a structural engineering, not only new structure, so we also need to take care, we also need to pay attention to the existing structures. So before, we analyze, we design the structure. During the life cycle, if this is subjected to damage or if this is it undertakes earthquake load or the wind load, so we need to monitor and inspect if there is any damage. If it is, we need to retrofit the building. This is the mission and assignment after earthquake or after load. So this photo shows some test results. For example, we carry out some tests on ductile steel connection, and so that we can guarantee that structural design can satisfy the strong column and the weak beam. And then the expected ductile behavior will occur. So you know that even this is a civil and structural department, but the concept is the same. As I mentioned, making a very strong structure, this is not difficult, but this is not efficient, and this is not doable practically. Except for rather than the strong structures, we hope that we can make a ductile and ductile structure with a sufficient strength. So which is called that this is a tough structure. So that's why here toughness is not given here. But this is what I want to emphasize. The point is that in addition to strength, we also require the structure to have ductility. So in addition to steel connection, this is a photo about a beam to column. In this division, there is a structural laboratory, including strong floor and reaction wall. Also, we have a unidirectional shaking table. So 25 meter by 14 meter strong floor, 12 meter length, and 7.5 meter height reaction wall. So by using this facility, we can perform some static and some pseudo-dynamic testing on a full scale on spaceships. Also, shaking table using actual dimension is 3 meter by 3 meter. So as you can see, if the table is there, the maximum acceleration is up to 3.2 g. The full payload is 10 tons. With the full payload, the maximum acceleration is up to 1.2 g. In addition to this big facilities, we have uniform testing machine with the capacity equal to 600 tons. So by using this universal, the big scale, large scale universal testing system, so we can apply a very large compression force to some structural components, which is designed to sustain the vertical load, for example, like column. And we also have many actuators, as I mentioned. We can mount this actuator on the reaction wall so that we can carry out static and pseudo-dynamic tests. And also we have many measurement instrumentation, accelerometer, and displacement transducer, low cell, and some non-contact, which is an optical measurement system. In this division, the construction material. So we focus on the material, the concrete material, and we focus on some corrosion issues. And in addition to concrete, we also invent some circular materials like these materials. And the pavement material. This is also very unique in Taiwan because the department, this issue, this subject is very rare in Taiwan University. So it's very unique in our department. And we also developed some solar glasses, which has been used in some high-tech factory. And the sponge city is very important issue right now in the future. So we know that we can hope the society, the city, have very strong capacity to resist any disaster. This is not realistic and this is not feasible. So therefore, the slogan of a sponge city is that even we are not sufficiently strong, but we still have some flexibility, we still have some ductility, so that we can sustain some extent of damage. And even so, we can repair the damage after this disaster very soon and restore the normal functionality. Okay, so this is the principle of sponge city. So which is the same as the principle used in structural design, as I mentioned. So we also have the materials laboratory so that we can do some material tests in this laboratory. In construction material laboratory, also we have some the medium scale universal testing system, 100 ton, 200 ton universal testing machines. So as you can see, we have so many testing facilities. So being a undergraduate student, so you can, when you study some courses, if needed, you can also use this testing system, and you can learn some skills, which is very useful for undergraduate students. Information technology. Some recent topics like cloud for computing and surface, and IoT to have a smart building. So as you can see that if you stay in this building, even you don't go out, you can have all the information, like the healthy condition of the building, the weather outside, and some emergency or some news. Visualization, VR and AR. you don't need any physical interface. You can still do some analysis, do some design, or even do some simulation. BIM, this is a very powerful model. During analysis, during design, during construction, and even after the structure is completed. By using this model, we can record anything, any details about the structure. So it's very useful for architecture, for structural designer, and for civil engineering designer, and even useful for owners. Once it is completed, if you want to trace some detailed information, so we can refer to this model, which has anything, any detailed information about the structure. So how to make a superior design? So by developing some powerful and useful tools, which can help design more efficient and better. And better construction, so this is also another advantage of adopting BIM, this model. A safer word, by using some technology or by using some result developed by this division, we can provide safer environment for laborers, for workers. And IT. Three-dimensional spatial mapping. So we can use a combination of LiDAR and UAV so that we don't need to hire physical labor to do some dangerous job on site. And intelligent image processing, this is called deep learning and spatial information application. So that by using knowledge base, language understanding, dialogue management, and context learning. So by combining this information, so we use a response generation, then we can announce some useful information to people. So in this division, we also have a very powerful laboratory. Let's skip the details. And also we have a surveying laboratory. So about this is the statistics about the students in our department. As you can see, up to now, there are in total more than 250 PhD graduates and more than 3,300 master graduates and more than 5,500 bachelor graduates. If we count the number per year in average, 400 graduate students and 380 bachelor students. So in the last semester, academic semester, in the last academic year, there are 32 PhD students and 278 master students and about 380 bachelor students. So where are these international students from? Including some countries like Indonesia, Vietnam, Philippines, Russia, Thailand, India, China, Turkey, Russia, Iraq, Peru, and Czech Republic, Hungary, Saint Lucia, and Ethiopia, Kenya, Gambia, Sudan, and so on. And we have a very strong and activity association, which is called International Student Association of Civil and Construction Engineering. The abbreviation is ISACCE, which was established in 2010. because of this association, so this association frequently hold many activities and many some lectures, so that this international student and even domestic student can work very well, and also by because of this activities, so they are very familiar with each other. So right now, for international students, we have about 60 PhD graduates and 287 master graduates. In the last academic year, 35, 60, and 24 for PhD, master, and bachelor students, respectively. So you can see that if we count the number in average, this is about 76. And why we have 24, the bachelor international student, because we know that most are from Paraguay. So alumni, international alumni. So this is a picture taken 2 years ago. So our alumni include this international students, PhD and master. So our alumni is very active and very strong. And they annually arrange some activity and almost come back on our campus every year. So do you need a break? 10 minutes break, okay? 10 minutes break.
Dear students, there is a small announcement that before for TSMC2, we are going in two groups separately. But right now there is a change. All the two buses will go to TSMC first and then to DIY. So all will go together but in a separate groups. But we will go together to TSMC and DIY. There will be no alternative shifts. Okay? And this is the structure of TSMC2. There are some students which have not filled properly the Google Sheet, the Google form. So these students can meet TA Felix after the class. Okay.
Guys, let's start the class. Our department has a very successful internationalization because we have more than 20 years experience teaching and guiding international students. And you can see that from the previous slide. So these students are from diverse countries. So, so we also, so because of association, that was established 10 years ago, and because of this association and because of our frequently arranged activities, so there are good interactions between students, including international students and domestic students. And because of accredited degree program, so that our diploma, we can use our diploma to go abroad to apply job, to apply university, and also for the undergraduate students, we plan the 2+2 English program, lecture program, and also our department, actually our university, offers several chances for overseas. Several overseas activities, and also we can provide partial financial support. And also we can provide scholarship if we are qualified in terms of your score, in terms of your performance, academic or some other performance. So this figure shows some partners in global, in Asia, in Europe, in US, in Indonesia, Korea, Japan, and so on, Philippines, Singapore, and so on. This is from the department level. So we also have many international collaborations. For example, like we offer bachelor, master, PhD degree, and dual degree programs, 1+1 for master degree, and 2+2 for bachelor degree. And we have so many chances to exchange students also for professors, so that you can have so many chances to visit other countries and other universities. And we also provide several laboratory internship chances. And also, we arrange intensive courses, 9, 18, or more than 18 hours. And during the summer vacation, we frequently hold some summer camps. About the industry link. So most of you may be, very interested in this part, because after your graduation, you are curious. So what kind of job you can do, and how many connections you can have during your stay in our university. So right now, for many professional societies, the current presidents are our alumni. So this is very important because it means that this is important, the roles. So our alumni take a very important position in our industry. Also, many courses arranged by our department. So we have lectures given by experienced industry experts. And also we arrange several field trips so that in addition to basic knowledge, you can also learn some practical. You can also touch some practical engineering projects. And in our department, we have so many collaboration, industry and academia. We have so many projects. So it means that we have sufficient research funding. And also, as I mentioned, we will provide, we provide several practical training opportunities. Also, these opportunities are with salary, with payment, during the summer vacation or during the semester. So you can choose either one to learn more practical stuffs, some practical engineering, analysis, designing, and construction projects. So about your career plan, if your goal is to do some practical jobs in the industry, so maybe your job, the contents of your job includes planning, design, supervising, consulting the company, contract professional engineers, architecture firms, and so on. So this is some the companies in the industry. Also, you may be a contractor to responsible for some construction and contract jobs. So you may work in construction companies and contractors. And also you may be involved in some jobs, operation and maintenance. So in addition to profit industry companies, you can also work in the government. like central government or local government. In addition to these two choices, of course, if you are more interested in research and teaching, some academic things, and you can choose being a professor, being a teacher for your career plan. So here, I want to emphasize that this is an old conventional concept. If you compare structural engineers and the architectures, so most people may feel that being an architecture, they are always beautiful with a very beautiful appearance. But being a structural engineering, so they are always dirty. Okay, so this is a conventional concept. Actually, right now, especially in this century, so we should change this conventional concept. Because being a structural engineer, in addition to the basic knowledge, you also need to have a capability to incorporate some new high tech into this industry. And also you need a very professional knowledge and a very professional experience so that you can play this role very well. So, in addition to this issue, so our industry, because our job is related to people's livelihood and welfare, and we try our best to mitigate disaster, some damage and some impact due to disasters, and we try to prevent damage. So also, this is a greatly related to country's economic development. So in a word, let's conclude. After your graduation, you don't need to worry about how to find a suitable, acceptable, and good job. Also, if you look at this flow chart, you can see that in Taiwan, since 1974, there are so many large-scale construction projects, infrastructure projects. It speaks that this industry is necessary for the country, for the government, and even for people's life. So, emphasize again, no worries about finding jobs. Also, compared with other industries, such as high-tech industry, being a good structural engineer, we need more experience. So, the more experience, the more the value. This is quite different compared with technician or engineering in high-tech factory, in high-tech industry. So you know that engineers in high-tech factory, in high-tech industry, always replaced very easily. But being a structural engineer, this is not easy to be replaced. It's because that when you get older, it means that you have more experience. And it means that this is more difficult, for you to be replaced. So that's why I emphasize the more the experience, the more the value being a structural engineer. In addition, our product is very large and it is durable. So it means that when you design, when you build the structure, the life you design should be at least 50 years or even more. So this is a durable. So compared with high-tech product like iPad or iPhone, which very easily to be replaced. So also the modern construction. This is also very important because right now we need to have a capability to combine some high-tech products into our industry, so that we can make not only strong but also robust structure. So I just use this slide to show you that, structure, civil and construction engineering department is highly related to our life, including food, clothing, housing, transportation, education, and entertainment. So which are classified as welfare rights. And also about the development of a country and development of major industry, for example, like energy industry and high-tech industry. The development, the successful development of this industry actually depends on our industry, depends on the civil engineering. It's because that everything should be located in a safe structure, so that the development of this industry can be guaranteed. So I also use this to emphasize the importance of our industry based on Maslow's the need, the requirement. So we know that some people need the self-actualization. So some people need esteem. Some people need love and belonging. And some people think that safety is important for them. But most people need air, water, food, shelter, sleep, clothing, and reproduction. These physical requirements. And you can see that these physical requirements are highly related to our industry, civil and construction engineering. So let me introduce some representative cases. So for example, like housing, the Taipei 101, of course. So why we have Taipei 101? This is a contribution of civil and construction engineering. So we know that this is the Harvard's building. This is one of the famous skyscrapers in the world. And for this building, in addition, so we encountered several difficulties. For such high the building, so how many materials, how large cross-section we need to design? Because, as I mentioned, Taiwan is a multi-hazard region. So we have wind, we have earthquake. For this super high building, so which load is the most important? Which load is the most dangerous? So being a structural engineer, so you need to have this capability to analyze, to design, and to determine all the cases to design this building, to build this building. And within this building, there is a very special design, the TUST standard, So you can use Google to look at the motion of the TUST standard, the TUST standard. The purpose of the design of the TUST standard is to resist the wind-induced response. In a word, this building, for a super high building, is dominated by wind-induced response rather than seismic response. In Taichung, this is the well-developed in the past 20 years. And also this one, Taipei Taozhu Yingyuan, this is the most expensive mansion in Taiwan. So I remember per meter square should be more than 1 million NT dollars. So this is the most expensive mansion in Taiwan. So you can see that the structure, the architectural appearance is very special. It's special. Because the architecture tried to design this building so that the residents inside this building, for each floor, so the residents can see the whole Taipei city. Okay, so that's why the structure, the architectural appearance is very special. So it seems like this is always rotated, because of its irregular design. So therefore, for this structure, we use a seismic isolation. We use a seismic isolation system composed of a friction pendulum bearing, which can overcome this irregularity, so that it can effectively reduce the torsional effect. In Kaohsiung, now this is another the highly populated area in Taiwan. Transportation, Taiwan high-speed rail system. This is a very important milestone in our industry, and also the metro, MRT, and also the third international airport in Taoyuan Airport, the third terminal in the Taoyuan Airport, and this is very important. Also, the highway, the fifth highway, the Xueshan Tunnel. Okay, so this is very top for our industry, but we still, our seniors still overcome all the difficulties. And Danjiang Bridge. So it's almost completed. So at the end of this presentation, of this lecture, I will show you a video. This is about the design and the construction of the Danjiang Bridge. So when you see the video, so you can really feel the importance, and you are really impressed of the significant contribution of being a structural engineer. And the Jingmen Bridge, this is another long span bridge to connect different islands in the Jingmen area. And also, this is a very special. This is Pingdong, Kaohsiung-Pingdong Bridge to connect Kaohsiung and Pingdong. So you can see that there is a very special design here. So we know that for this area, so the boat passed through this river. However, because of this obstruction, because of this bridge, it may stop. It may affect the regular the transportation of the boat. So therefore, this is a very special design. This deck can be controlled to be erected so that the boat can successfully, smoothly pass through this way without any difficulty. And after passing, this deck can be controlled to be closed. So about food include some reservoir, some irrigation, and some dam design. So those are very important. So those are also the contribution of civil and construction engineering. So why I said that we are always related to education? Because during the 1999 Jesus Quake, during that earthquake event, so many the school buildings were collapsed. So therefore, we launched a very important, very special program to retrofit all the damage, and even this is potential dangerous the buildings, the school buildings. So, in addition to the school buildings, this is the South Branch of National Palace Museum. As you can see, if you compare this one with the Taozu Yuan, you can see that both have the same feature, very irregular. Very beautiful but irregular architectural appearance. So therefore, for this design, we also use a seismic isolation system. So this is very special. And this is a Tzu Hospital in Taipei. This kind of building is very essential given an earthquake. So why I say that is because for typical building like a residence building, even this building have some damage during earthquake, it's not a big issue. But we should guarantee the functionality of the hospital during an earthquake, so that this hospital can rescue some people, some patients. So therefore, for this structural design, we also use seismic isolation system. Entertainment, Taipei Performing Arts Center. Again, because of irregularity, we use the seismic isolation for this building. And also, at the end of this lecture, I will provide a video regarding this one. And Kaohsiung Weiwu, Taichung Theater, and Music Center. So you can feel, to design a structure, not only safety, but also attractive appearance architecture. Important. This is the mission, and this is a challenge, being a structural engineer currently. So we don't satisfy safety. We also require the building, the structure, being very attractive in appearance. Economic development, like energy industry, the biotech and high tech. So all of these are related to civil and construction engineering. So we can imagine that a structure designer, the role is like a doctor. To patients, a doctor cure patients. For a structure, a designer analyze, design, constructed the structure. Also, during the life cycle, structure designer also need to monitor the healthy condition of these structures. Here I just show you some damage, the situation during the past earthquake, and this is the building collapse during the 1990 earthquake. So you can see that if the building is not strong enough, or if this building is not ductile enough, so it cannot sustain such a large earthquake. So during the earthquake, there is a very severe damage and even collapse during the earthquake. So this year, so most of you must remember this event. Okay, so this earthquake in 2016, Meinong earthquake. So there's a building collapsed during this earthquake. 2018 Hualien earthquake. So there's a very severe damage for this building. And so during this event, and during the Chichi earthquake, actually we observed some features, the seismic features. So this is a very professional issue, so I don't want to talk details here. In addition to earthquake event, we also have flood event, flood issue. So during a typhoon, you can see that this deck was collapsed due to the flood. So in addition to some nature hazard, so we also have some issue induced by people. For example, like this one, Taipei Arena. So let me show you some video. Actually, this is the job of, this is also the job of structural engineers. So you can see that after we completed this, the gym and the famous singer, so how does the council in this gym? Well, it should be not a big deal, but we can see that the residents around this gym can feel the vibration because of this concert, especially for a special song. 3 days, 3 nights. So this is our job, to solve this problem. So that's why I say this is not enough to have a safe structure. So in the future, right now in the future, so the requirement becomes stricter. Okay, let me show you another one. About the impact. The effect of this concert. So you can see the vibration of ceiling light. 从去年呢，才愿意发放周边7个里10万块的敦亲护林费用，但是住户觉得这样太不合理了，昨天直接找上了柯文哲拦路澄清。说你帮我解决，我每天地震忍受那个计划4口怎么办？假日登山践行放松去，他不像柯文哲，却没料到会与市民半途拦路澄清。我们住在那边真的很怕，很怕。神奇的就是之前还闹上新闻版面的小巨蛋受灾户。So you cannot imagine that this is caused by the cancer, the signal, rather than earthquake. 之前的还有一次地震，10场演唱会同样的状况，几乎天天上演。从6楼冲下来，然后按那个紧急求救铃，要求救，这样会小绿灯不顾。问题悬而未解。So the government asked me, to deal with this problem, to solve this problem. So this is all things are real. Okay, the resident also showed me the video about the vibration caused by the cancer. So this is real. But, during the analysis, during the design stage, if the structural designer did not consider this issue. So right now, actually, it's become more difficult to solve this problem. So therefore, during the concert, we analyze the model and try to use the real measurement to correct the model. And showing this figure, I ask my students to measure the real response. And this is when there's no activity in this room. And also after the famous singer, so our group also measured so many signals, so many data from other concerts. For example, like Xu Jiayi. So we can attend the concert without pay. It's because that we need to measure some important signals during the concert. And also we propose some strategy. For example, like so you can use some isolation design to isolate the vibration, cutting to the surrounding. But this is not the most effective. The most effective strategy is that to ask all the attendants not to jump during the concert. So this is the most effective solution. So this is a night. This photo is taken. This is the night view of the Taipei city. So you can see that very crowded, there's so many high-rise buildings and the highly populated. Everything is fine, everything is beautiful, but can you imagine that according to the statistics, so we have so many earthquakes per year. So in which more than about every year about 23,000 earthquakes, and 1,000 you can feel the vibration, and one destructive earthquake which can cause some damage. So intensity average every 15 days, 4 to 5 intensity earthquake occurred. So you can see that for our city, especially for Taipei City, this is not enough to ask all the structures to have sufficient strong, sufficient accepted performance or sufficient capacity to receive earthquake. This is not realistic. And in fact, this is impossible. So we propose another strategy. So even we cannot ask all the structure to be very strong, but we can try our best to make this city to be a resilient city. What does it mean? It means that after a disaster, we still have a capability to restore the city. In other words, we can restore everything. We can restore the regular functionality a few days. So this is sufficient, and this is the code, the resilient city. This is our goal. This is our goal. So let me take an example. In 2011, this is a Christchurch earthquake in New Zealand. Before earthquake, everything is fine. After earthquake, so almost everything was demolished. This is what I want to emphasize. So the effect of earthquake is very significant. It's very scary. It can destruct all the city. So here I just use some videos to let you understand the details about Danjiang, the Danjiang Bridge. And this video is provided by a famous consulting company in Taiwan. So the video, we have English critic. Even the voice is in Chinese.
北部的淡水河口，一座卓尔不群的大桥即将在此处诞生，其名曰淡江大桥。这座筹划已久、优雅壮观的桥梁，宛如一位身姿轻盈的舞者，沐浴着众多期许的目光，从陡壁来到舞台中央。它跨径长达450公尺，是现今世界上跨度最大的不对称单塔斜张桥。全长920公尺，塔高180公尺。首先进行桥塔基础施工，利用围堰配合全套管基桩打设，逐步完成。塔柱塔身。使用爬山模架进行混凝土浇筑施工。与此同时，淡水端的两侧跨在不进入浅水区域的情况下，也开始采用吊装，以推进整跨施工。上部结构，大梁则由桥塔及自由悬臂分别朝向淡水及巴黎进行施工，采用甲板吊装悬臂工法推进。直至淡水端侧跨完成闭合，再向巴黎侧继续吊装推进。此时，巴黎端侧跨已开始施工。最后，则进行最重要的系统闭合。透过准确的规划、精密的计算、优质的建造，共创历史性见证。主桥施工完成，预估应在民国110年的3月，与通车目标相距不远。施工中严密管控，没有严重的惊扰与破坏。完工后，对珍贵的水鸟而言，蛙子尾及本体家仍是家，熟悉的温暖不曾改变。请看，当夕阳西下，淡水河口那道令人陶醉的景致，轻盈的舞者瞬间宛如害羞的新娘，在晚霞中红透的脸颊，仿佛低声诉说着这座建筑和这方水土那永恒的魅力。请看，当夜幕低垂，淡水河口那令人遐想的一幕，内敛的白色舞者在周边宁静的夜色中，眉眼生风，顾盼自如，与风为舞，与水而歌。
About the design and construction of the Art Performing Center, which is close to the night market, the city night market.
台北艺术中心由3个剧场组成，每个剧场都能独立运作。大剧院、多形式中剧场 和镜框式中剧场。3个剧场嵌入一个中央方形亮体，方形亮体把舞台、后场和支援空间合并成为单一而有效率的整体。台北艺术中心有许多个正面，观众席亮体于此向外铺伸，悬浮于这熙来攘往的城市之上。方形亮体从地面抬升，街道延伸至建筑物之中。对于没有购买剧场门票的一般市民，台北艺术中心同样欢迎您的造访。公共参观动线是一条穿越剧场设备空间和制作空间的通道。虽然这些空间一般都被隐藏，但当中的运作却令人叹为观止，好比一场引人注目的演出。公共参观动线不仅使观众亲身感受剧场制作流程的经验，更进而使剧场影响不同层面的民众。大厅是3个剧场共用的，观众在通往较高楼层的过程中逐渐分散。镜框式中剧场有800个坐席，像是悬浮的星球停靠于方形亮体。观众在球体内外壳之间穿梭，往剧场方向行进。在观众席内，内壳与方形亮体交界形成的独特镜框形式，创造了镜框可能性的无限想象。大剧院是3个剧场之中最大的，由一个隧道将观众从大厅带领到观众席。大剧院有1500个坐席，富现代感的设计是从20世纪的大型剧场空间演化而成。不同于传统的协和型剧场，大剧院的形状些微不对称。舞台层、主观众席和楼座区在折叠的平面上形成一体。它有着多变的声学效果，灵活的前舞台和乐池能支援各色各样的表演，例如舞蹈、芭蕾、中国戏曲、西洋歌剧，以至交响乐。与大剧院位处相同楼层，在它对面的则是多形式中剧场，是个可容纳最具实验性表演的灵活空间。超级大剧场是一个大型、类似工厂般的环境，由大剧院和多形式中剧场结合而成。这里能容纳各类大型制作，例如齐马曼的歌剧《士兵》，这部需要100米舞台来演绎的剧作。而那些超乎想象的新锐创作，更可在超级大剧场独特的空间中绽放异彩。
Okay, so I hope that you, after you see these movies, you can really feel the importance and the contribution of civil engineering to our society, our country. So it's time to end the class. Thank you.